Bacteria are around us all the time. Most of the time, we don't really notice them because they're way too small to see and they don't bother us. But we've all had an ear infection, strep throat, a UTI. These are things that are familiar across the world. Luckily for us, we have antibiotics. Unfortunately, these medicines are starting to not work as well as they used to. The problem isn't confined to just human medicine. Antibiotics are widely used in raising livestock, where they can go out into the environment and contribute to resistance there as well. These practices are projected to increase over the coming years. So, are we simply doomed to go forward into this future? No. We're human beings. We solve problems, and engineers have a critical role to play here. We are the ones who build new solutions, who take problems like this and discover how we can address it. Think about a natural, beautiful landscape, if you will. And if you really start to think about it, you'll realize that bacteria are everywhere. Yet in these situations, at no point is nature hitting everything with antibiotics across the board. Maybe there is information that we can gain from this, and maybe we can take that information and turn that into solutions for human problems. In our group at the University of Maine, we focus on bio-inspired engineering of materials. And we know that a lot of problems with bacteria really start when bacteria stick to things. So if we look at nature for an example of how nature has solved the infection situation that we're dealing with, maybe our best example is us. If you think about us and the place in our body where nature does the best controlling of bacteria is actually the place where the bacteria concentration is highest, in our intestines. It's all kept in balance when we're healthy. But at a very base level, one of the most important components is mucus. Mucus is an amazing material. At a fundamental level, it's basically just acting as a physical barrier. It is presenting these bacteria with a surface that is soft and moving and flowing and dynamic. So we asked ourselves, what if we just replicated that component? Could we get towards finding that balance that nature achieves? The answer, it turned out, was yes. We could fairly easily create a mucus mimicking system by adding a biocompatible liquid to a very commonly used solid, silicone rubber. And we found that when we did, indeed, we were able to create a mucus-like system. And importantly, we could treat any kind of medical device that was made out of this material. And we were actually able to introduce a fluid dynamic component to that simply in the form of a biocompatible liquid that would get in between those molecules in the material. When we did this, what we were doing was giving that material a mucus-like sort of surface. So in fact, we found that we could treat any type of medical device made out of this silicone rubber material. Urinary catheters are among the most commonly used medical devices. Unfortunately, due to the nature of where they are located, they're also one of the most prone to infection. We sent these materials to collaborators who specialize in catheter-associated urinary tract infections, and the results were jaw-dropping. We found between a 90 and 100% reduction in the bacteria that were able to stick to these materials, grow, and then spread to other organs. We weren't satisfied with stopping there, though. One thing that makes natural materials so amazing is their ability to change and adapt. We used 3D printing to engineer a vascular network within our silicone rubber materials. And we found we actually had created a system that would allow us to communicate with bacteria. So we were able to listen to the bacteria. When they grow and reproduce, they create compounds, and those compounds diffuse down from the surface into a liquid that we use to fill our vascular channels. But it went further than this. We actually found that we could infiltrate those vascular networks with materials that would instruct the bacteria to do specific things. So in this way, we were able to create a communication loop with the bacteria in a way that is approaching how nature handles it. We believe that being able to communicate with bacteria in this way, in real time, is going to give us a new set of tools for being able to look at bacteria as a potential partner in health and well-being for humans. Nature has evolved over millions of years to achieve balance with these organisms, and now we are working to engineer a part of that balance into human materials and processes.